Okay, so we saw in the previous video how to find this solution by separation of variables. And it's really important to understand that you can always check all of your solutions that you find by hand by just taking the derivative and substituting them back into the original differential equation and showing that you get a true statement. But to move forward in this problem, we're now going to go ahead and solve the initial value problem. And we see that y of 0 must be equal to -3. So that means that -3 must be equal to c times e to the 1/2 times 0 squared minus 2. And then to solve for this, we're going to simplify the exponential down. Of course, e to the 0 is 1, so -3 equals c times 1 minus 2. Adding 2 to both sides, we end up with our c equals -1. So our solution is y of x is equal to -1 e to the 1/2 x squared minus 2. And again, you could check the initial condition by just plugging in 0 as well. All right, the last part is to state the interval of existence. And you will notice that we have an exponential function that has a quadratic exponent. So there's no issues whatsoever with having to worry about division by 0 or roots of negatives or anything like that. So the interval of existence is actually all real numbers because this function is defined for all values of x, and it's differentiable for all values of x as well. So the interval of existence, again, is all real numbers, the entire number line.